Yes, hi students. We have already discussed part 1 of chapter 10, that is light. So today we'll be discussing part 2 of the same chapter. So let's start. If you have any doubt regarding your previous chapter and this chapter, then you can ask in the comment section. Feel free to ask there. So let's start from the first question. What could be the light that she placed inside the box to make the rays behave as shown? You have to tell what could be the x here. This one is x, so you have to tell, as you can see that rays of light when it strike on this surface, it goes in the same way, right? So you have to answer that which is the correct option. What type of this box, the central rectangular box which you can see over here, what is the type of it? So first option is a converging lens. The central one is a converging lens. Second, a parallel sided glass block. C, a plane mirror. D, a triangular prism. It's not a prism, we can see it because a prism is somewhat like this. Converging lens, the converging lens is a lens which converge all the rays of light falling on it. So no, because here no converging thing is taking place here. So next is a plane mirror. Plane mirror always forms a virtual and erect image, so which cannot be formed on the screen. So which option is right? A parallel sided glass block. I will tell you what is the quality of a parallel sided glass block. Let's say, first of all, we can see it is a parallel to each other. The opposite sides are parallel to each other. So when any ray of light strike on perpendicularly, like this perpendicular ray of light, so angle of incidence is 0 degree. So after passing through, after striking and after reflection, so it will pass undeviated. When angle of incidence is 0 degree, a ray of light will pass undeviated. It will pass straight without showing any deviation. So which type of surface is this central one? It's a parallel sided glass block. Clear? Okay students, so let's move to the next question. If a ray passes from air to glass in a spherical glass slab and passes through the center of the slab, without deviation, then angle of incidence from air to glass at the point on glass slab is, means when a ray of light is striking on a glass slab and after striking it passes undeviated without any deviation, what should be the angle of incidence? We already discussed it in our previous question. So in that case, angle of incidence is always 0 degree. Okay, next. In the ray diagram shown above, lens is placed in the dotted box. What is the type of lens used? As we can see here that a ray of lights are converging at a point. Let's say it's a point P. So which lens converges rays of light? Which lens? This one, convex lens. Concave lens always diverge, a ray of light falling on it, and convex lens always converge. As we can see here that rays of light are converging at one point, meeting at one point. Next. You have to guess the type of mirror placed at point P for the situation shown. What is the type of this mirror? Which type of mirror is this? As we can see that this is an object distance. This is an object where an object is placed, and this is the size of an image. Size of image, we call it h2, and this is height of an object, h1. Here we can see that size of an object is equals to size of an image. Which type of mirror is it? You have to tell. Obviously, there is one case of a concave mirror where object is placed at center of curvature, and in that case the size of object is equals to the size of an image. So which type of mirror is it? Concave mirror. Okay. Next. Take down this diagram onto your answer book and complete the path of ray. Do it with me. Draw this. Which type of lens is this? It's a concave lens. So just complete it. Complete this ray diagram. This type of questions can also be asked in your exams. So prepare these ray diagrams as well along with me. So tell me what will be the path of ray of light. As we can see, ray of light is coming from infinity, and also it's a concave lens. So after striking at the optical center, ray of light will go like this. Okay, and obviously it's a concave lens, so it will diverge the rays of light falling on it. Again, a ray of light will straight in this way, so it will also diverge like this. Draw it straight. You should use scale for this purpose because your ray diagrams should be neat and clean. So when you diverge these rays of light where they will meet, you can extend them like this. Very point size image will be formed at the focus. You already know this thing. When an object is placed at infinity, image is always formed at focus. Also it's a concave lens, so image will be formed like this, and size of the image is very small, very reduced images. This one, a dash b dash. Clear? So let's move to the next question. Complete the possible path of the ray through the glass slab that is shown below. Here, first of all, let's say a ray of light is coming from air and it is entering into a medium that is a denser medium, let's say water, right? So as we know, when light goes from rarer medium to denser medium, it always bends towards the normal. As this one is incident ray, angle made by incident ray with the normal is called angle of incidence. And when it goes from one medium to another, and in this case one medium is rarer to denser, it will bend towards the normal. It will bend like this. It will bend towards the normal. So angle made by this one is called a refracted ray. Angle made by a refracted ray with the normal is called angle of refraction. So again, when it changes its medium and it goes from denser to rarer medium, it will bend away from the normal. If it strike over here and it is going from denser to rarer, it will go like this, away from the normal. And this one is called emergent ray, and the angle made by an emergent ray with the normal is called angle of emergence. Keep this thing in your mind that angle of incidence is always equals to angle of emergence in this case. And one more thing, angle of incidence is greater than angle of refraction, because as if we take a case here, angle of refraction is formed in the denser medium and ray of light is bending more in the denser medium. So always we take angle of incidence greater than angle of refraction because of bending, angle of refraction will always be lesser than angle of incidence. Okay, so let's move to the next question. Redraw the diagram given below in your notebook and show the direction of ray after reflection from the mirror. As we can see from here that ray of light is passing through the focus and it is striking on a concave mirror. Which type of mirror is this? Concave. And concave mirror is a converging mirror. So after passing through the focus, when a ray of light strike through the focus, it will become parallel to the principal axis. It will go like this. Always mark an arrows whenever you are showing the path of light now. So it's very important to mark arrows. So when ray of light passing through the focus, it will become parallel to the principal axis. It will be like this. Next question. Redraw the diagram given below and show the direction of light ray after reflection from the mirror. You have to make a path of ray of light. Let's say when ray of light strike through like this, you have to meet this ray of light at the focus. So how it will meet? It's a convex mirror, so obviously it will diverge a ray of light falling on it. So we will meet it like this, and after striking it will diverge. And where will it meet? It will always meet at the focus. And in next case, ray of light will strike to the pole, on the pole, and it will pass obliquely after striking like this. So meet both these rays of light. So approximately they will meet at the focus and they will produce a very highly diminished image will be formed. When you draw these with the help of a scale, then you can easily draw them correctly. Okay, so let's move to the next one. Which type of mirror is used in the headlights of a car? Headlights of a car. You know that concave mirror will produce a parallel beam of light. So concave mirror will be used in headlights. Next. Which mirror is used in solar furnace to trap the rays of sunlight and to produce a parallel beam of light? Always a concave mirror will be used. Which mirror? Concave. Next. All distances are measured from dash of the mirror. I hope you remember the sign conventions where there is a pole. This one is principal axis. This is a pole. All distances are measured from the pole. The ray of light that is along the direction of the pole will be taken as positive, and the rays of light opposite to the direction of pole will always be taken as negative. So all distances are measured from the pole. Next. Distance measured upward to the principal axis are taken as upward, like in this way. Upward is all like object is placed upwards, so you will take it positive or negative. Positive. Downwards will be taken as negative, and you know in case of downwards a real and inverted image is formed if an object is placed in front, and if an image is also formed at front and also inverted, so we will take it as negative. Upward will always be height upwards will always be taken as positive. So which is the right option? Positive. Next. Distances measured in the direction of incident light in case of a spherical mirror are taken as in the direction. In the direction, I told you this thing already, positive. Next, a spherical mirror and a thin spherical lens each have a focal length of minus 15 centimeter. So the mirror and the lens are likely to be, both are having a focal length of minus 15 centimeter. Focal length is negative in which case? Remember that. Focal length negative. Concave lens. And which mirror? Concave mirror if it is in front of the mirror in that case. So which option is right? Both concave. You have to tell the lens. The mirror and lens are likely to be. The mirror is concave and the lens is convex. Convex lens always have focal length positive. Mirror is convex but lens is concave. Concave lens negative. Both convex, both concave. So right option is both concave. Why both convex is not a right option? Because convex mirror and convex lens, they have a positive focal length. And mirror is convex but lens is concave lens will form a negative focal length and जो convex mirror होता है वो positive बनाता है. So right option is A. Next, to determine the approximate focal length of the given convex lens by following a distant object, you try to focus the image of an object on a screen. The image you obtain on screen is always erect and laterally inverted, erect and diminished, inverted and diminished, virtual, inverted and diminished. First of all, you are using a convex lens over here. So you know that convex lens will always form which type? Diminish is only in case of concave lens. So which option is right? Yes, diminish. Just remove this option from here. Diminish, remove it. Diminish, remove it, because concave lens will form a diminished image, very diminished image. So right option is A. Which of the following material cannot be used to make a lens? For making a lens, a transparent medium is needed. So from all of these four options, clay is the right one because clay is not a transparent material. Next, a student has traced the path of a ray of light through a glass slab as follows. If you are asked to label angle 1, 2, 3 and 4, the correct sequencing of labeling angle I, which is angle of incidence, comma angle E, angle of emergence, angle R and lateral dispersion respectively. So which is the right option? You have to answer that which option is right. Angle of incidence is obviously this one, angle 1. This is angle of incidence because angle made by an incident ray with the normal is called angle of incidence. And angle made by refracted ray with normal is angle R. And angle made by the emergent ray with normal is angle of emergence, and this is lateral displacement. An extended emergent ray and the incident ray, the angle between an emergent ray, extended emergent ray and the incident ray is always lateral displacement. So this is lateral displacement. So you have to tell angle of incidence, angle 1, angle of emergence, angle 3 and angle R is angle 2 and lateral displacement is angle 4. So right option is this one. Okay, so next question is select from the following the best experimental setup for tracing the path of a ray of light through a glass slab. Which is the best experimental setup? Let's observe a ray of incident light, a way in which an incident light is striking on a surface. So this is acting normal, so no. So this is bending a lot, no. So it is just striking along the surface, so no. So which is the right option? First one. Okay. Next, When you focus the image of a distant flag whose shape is given below, see the shape of a flag, on a screen using a convex lens, the shape of the image as it appears on the screen is. So we know that convex lens, there is only one case where it forms a virtual and erect image when an object is held very close to the lens. In all other cases, it always forms a real and inverted image. So which is the right option? Real and inverted. Inverted means if an object is upwards, then image is formed downwards. So this is inverted. So which is the right option from here? This one, option A. A student very cautiously traces the path of a ray of light through a glass slab for different values of the angle of incidence. He then measures the corresponding values of angle of refraction and angle of emergence for every value of angle of incidence. On analyzing, his conclusion would be, so we know that what is angle of incidence. If this is angle of incidence and this one is angle of refraction, again it is striking on the normal, this is angle of emergence. So keep this thing in your mind that angle of incidence is always equals to angle of emergence, and moreover angle of incidence is greater than angle of refraction because it's a denser medium, so bending will be the most in this case. So angle of incidence is always greater than angle of refraction. So what is the right option from here? Choose the right one. This one, B part. Next, a ray of light traveling in air is incident perpendicular to the boundary of a parallel glass slab. The ray of light is then, what will happen to the ray of light after hitting or incidenting perpendicular? Is refracted towards the normal? Is refracted away from the normal? Is refracted along the same path? D is refracted. C option is right because I already told you that when a ray of light is, if this is a parallel glass slab and ray of light is incident perpendicular, so angle of incidence is 0 degree and it will pass along the same path. Next, when a plane mirror is rotated through a certain angle, so the reflected ray turns through twice as much and the size of the image plane mirror will form an exact image as that of object. So you should remember some things about plane mirror. The angle of incidence, the distance of an object is equals to distance of an image, the height of an object is equals to height of an image. So plane mirror is a mirror which is in your homes, which you see, in which you see your image daily, right? So which is the right option? If the reflected ray turns through twice as much and the size of the image will also turn, is also doubled, na? Yes, is doubled because it's the case of a plane mirror. Which statement is true for the reflection of light? First, angle of incidence and reflection are equal. Angle of incidence is bright than the angle of reflection. The sum of angle of incidence and reflection is always greater than, let's say 1. The beam of incident light after reflection diverge at unequal angles. So which is the true or right statement? So angle of incident and reflection are equal according to the second law of reflection. Angle of incidence is always equals to angle of reflection. Let's say this is a mirror, a ray of light is striking like this, it just changes its path. Otherwise angle of incidence and angle of reflection is same. Keep this thing in your mind. Let's move to the next one. Focal length of a plane mirror is what? Infinite. Next, a beam of light incident on a plane mirror forms a real image of on reflection, it forms a real image. Okay, so the incident beam is parallel, convergent, divergent, not certain. So convergent will be a right option as it is forming a real image. So if a real image is formed, then it will always converge at one point and it can be formed on the screen. So convergent is the right option. Next, image produced by a convex spherical mirror is convex spherical mirror. What type of image? There are two cases of convex mirror. So you have to tell what type of image it forms. Enlarged, no. It always form a diminished image or very reduced size. Inverted, no. Real, no. Virtual. Because you have to extend the image. And the image that cannot be formed on the screen, but it always extends. So that image is always virtual. Next, the image of an object placed in front of a convex mirror is formed at where? The object itself, twice the distance of object in front of the mirror, half the distance of object in front of the mirror, behind the mirror. So when an object is placed very close to the convex mirror, so where very close or in front of a convex mirror, so there are two cases of convex mirror I already told you. So in that case, image is always formed where? Behind the mirror, because it forms a virtual image, so it will form behind the mirror. Next, beam of light is incident through the holes A and B and emerge out of box through the holes C and D respectively. So which of the following could be inside the box? It is similar like our first one that we discussed already. So you have to choose the right option. A rectangular glass slab, a convex lens, no, because convex lens is always converge. Concave, no. A prism, no, it is not looking like prism. So which is the right option? First one. A rectangular glass slab has both opposite sides parallel, we can say. A full length image of a distant tall building can definitely be seen by using which type of mirror? Full length image. A concave mirror, a plane mirror, a convex mirror, both concave as well as plane mirror. We can say convex mirror because convex mirror will form a erect image or virtual or erect image. So convex mirror will be a right option. Next, the laws of reflection hold good for plane mirror only, concave mirror only, convex mirror, all mirror irrespective of their shape. We know that laws of reflection are applied on all type of mirror. There is no particular case or particular mirror on which it is applied. It is applied on all mirrors. Next, light travel fastest in water, air, glass, diamond. Speed of light in air is fastest. That is 3 into 10 is to power 8 meter per second. In all other cases, it is less as compared to air. Next, the mirror having reflecting surface curved inwards. Reflecting surface, like you can relate it with front side of the spoon. Front side of the spoon, rays of light when strike on it, it always converge inwards. What type of mirror is that? Concave mirror. Next, the deviation of a light ray from its path when it travels from one transparent medium to another is called deviation. Means bending of light ray when it goes from one medium to another. What we call it? Reflection? No, reflection is bouncing back of light ray. Refraction, dispersion is splitting of light ray into 7 colors. Scattering should be here. No, scattering won't take place. So what is the right option? Refraction. because refraction is basically a bending of light ray when it goes from one medium to another. Medium play a very important role in case of refraction. Next, the image which is formed behind the mirror. It's always a virtual that cannot be formed on the screen. Next, these are fill in the blanks. So you have to choose the right one. When light ray falls on a surface and bounces back to the medium, the phenomena is called, obviously, reflection. Next, when a ray of light after reflection when it meet at a point, what type of image is formed? Real, B is virtual. When it meets, then it is called real one. Next, the dentist used dash mirror to see large images of teeth of patients. Dentists use concave mirror for this purpose because when a concave mirror is placed very close to the surface, then it will form a larger image to see a broader view, to see teeth of patients properly. Concave mirror is used. Next, power of a convex lens is positive and concave lens is negative, because focal length of concave lens is negative and power is inverse of focal length. Okay. Next, mirror having magnification always equals to 1. What type of mirror is it? Plane mirror, convex, concave, biconcave. So plane mirror is the right option, because you know that what is magnification? Magnification is, if I relate it, it is V upon U. It is also H2 by H1. In case of plane mirror, everything is equal. So if everything is equal, if I say object distance is 1, then image distance will always be 1. So magnification is always 1 in case of plane mirror. Next, bottom of a tank containing water appears to be raised due to. It's a phenomena that is called a refraction. Next, the lens which is thicker at the middle and thinner at the edges. What type of lens is this? Which is thicker at the middle. Thicker at the middle and thinner at the edges. Which lens is this? It's a convex lens. Next, now there are some assertion and reason type questions. So these are the options which are given to you. First option is both A and R are true, and R is the correct explanation of A. B option is both A and R are true. A means assertion and R means reason, and R is not correct explanation of A. C is A is true but R is false. D option is A is false but R is true. So firstly read an assertion properly and reason as well. Then choose the correct one from these options. So lateral displacement is the distance between incident ray and emergent ray. I told you this thing already, it's right, because when incident ray is extended and emergent ray as well, so the distance between them is called lateral displacement. So that is right. Reason: the wider the glass slab, the larger the lateral displacement. So both are right at their own place, but reason is not the correct explanation of an assertion. So B option is right. Next, higher is the refractive index of a medium, or denser the medium, less is the speed of light in that medium. We know that refractive index, more is the refractive index, del is equals to A mu minus 1. So more is the refractive index, more will be the deviation. Less is the refractive index, less will be the deviation. So you have to choose higher is the refractive index or denser the medium, less is the speed of light. And also refractive index is inversely proportional to the speed. Reason, refractive index is inversely proportional to speed. So I think this is related, reason is related to assertion, right? Because this reason is an explanation of this assertion. Because refractive index is inversely proportional, that's why more is the speed, less will be the refractive index, and less is the speed, more will be the refractive index. So A option is the right one from here. Next question, assertion. As temperature of a medium increases, the refractive index decreases. More is the temperature, less will be the refractive index. Next, reason. When a ray travels from vacuum to medium, then N is absolute refractive index of the medium. Both of the temperature, how temperature is related to the refractive index. See, if a temperature is, if there is a hot air, so that is a rarer medium and their refractive index is less. Okay, rarer medium you already know has less refractive index. And if there is a cold air is called denser one and refractive index is more. So obviously refractive index is related to the temperature. More is the temperature, less will be the refractive index. Okay, so which is the right option? Both are right at their own place, but they are not the correct explanation of each other. So B is the right option from here. Next, a ray of light in, read an assertion properly. A ray of light incident normally on a mirror retraces its path. Reason, in reflection, angle of incidence is always equals to the angle of reflection. So tell me, are these both true? Normally it will always retraces its path. Okay, so the second one is, for in first case we are talking about the refraction and in second one we are talking about reflection. Both are true, but reason is not at all a correct explanation of assertion. So B is a right option. Next, the angle of incidence for a ray of light having zero reflection has, what is an angle of incidence? 0 degree, 30 degrees. Zero reflection means no reflection will take place, a ray will go undeviated. So choose the right one. 0 degree, 30 degree, 15 degree, then 90 degree. 0 degree will be a right option. Next, which of the given is not these of an image formed by a plane mirror? Which of these is not a characteristics of an image formed by a plane mirror? It is erect first. B option is image is virtual. C, it is diminished. D, it is at same distance as that of objects. So which is erect, right, virtual, right, same distance I already told you. So which is not a right option? It is diminish. This is wrong. Next, a man run towards the plane mirror at 2 meters per second. Man is running towards at 2 meters per second. The relative speed of his image with respect to him will be double, 4 meters per second. Next, a ray of light passes from a medium X to another medium, that is Y. No refraction of light occurs when a ray of light hits the boundary of the medium Y at an angle of, I think we have done more of these questions previously as well. So you can easily answer me that what is the right option where there is no refraction. A is 120, B is 90 degree, C is 45 degree, D is 0 degree. So right option is 0 degree. Next, The angle of incidence I and the angle of refraction are equal in transparent slab when the value of I is 0 degree, 45 degree, 90 degree, and depend on the material of the slab. So which is the right option? When is an angle of incidence equals to angle of refraction? When a ray will pass undeviated, in that case, let's say if this 0 degree is an angle of incidence. So when a ray is passing undeviated straight, so in that case, there will be no angle of refraction. So angle of refraction will also be 0 degree. So what is the right option? 0 degree. So I hope all these questions are clear to you, students. If you have any doubts, then you can ask your doubts freely in a comment section. So till then, bye bye.